In programming, data structures and algorithms are the foundational building blocks that dictate how software applications handle data and perform tasks efficiently. Understanding these concepts is crucial for any software developer, as they directly impact programs' performance, scalability, and efficiency. Today, we'll talk about the definition, some basic data structures, and algorithms. This is a blog post from Hao Ly, founder of AlgoSync. Let's get started. Definition of data structures. A data structure is a specialized way to organize, manage, and store data for efficient access and modification. Different data structures are designed to suit specific types of operations, enabling developers to store and manipulate data effectively. What is an algorithm? An algorithm is a set of well-defined instructions for solving a particular problem or performing a specific task. Algorithms take data as input and produce an output, often through a series of logical steps. The efficiency of an algorithm is measured in terms of its time complexity, how fast it runs, and space complexity, how much memory it uses. Real-life example of data structures and algorithms. Imagine you are organizing a bookshelf. How you arrange your books and the method you use to find a particular book are akin to data structures and algorithms. Data structure. The bookshelf is a data structure. If you arrange books alphabetically by author, you are using an array-like structure where each position corresponds to a specific book. Algorithm. When you want to find a specific book, you might start from one end and check each book one by one until you find the one you need. Basic data structures. Here are some of the most commonly used data structures. Array, a collection of elements identified by index or key. Arrays are fixed in size and allow constant access to elements. Linked lists, a sequence of nodes where each node points to the next. Linked lists allow for dynamic memory allocation and efficient insertions and deletions. Stack, a linear data structure that follows the last in first out, LIFO, principle. It's used in scenarios like undo functionality in text editors. Queue, a linear structure that follows the first in first out, FIFO, principle, often used in task scheduling and handling requests. Trees, a hierarchical structure with a root node and child nodes, commonly used for storing hierarchical data, like file systems or databases. For example, binary trees, AVL trees. Graph, a collection of nodes, vertices, connected by edges used to represent networks, such as social media connections or city maps. Hash tables, a data structure that maps keys to values, providing fast access to elements based on their keys. Basic algorithms. Some of the most commonly used algorithms include sorting algorithms, methods to arrange data in a particular order. Examples include quicksort, merge sort, and bubble sort. Searching algorithms, techniques to find an element within a data structure. Examples include binary search and linear search. Traversal algorithms, ways to navigate through data structures, especially trees and graphs. Examples include depth-first search, DFS, and breadth-first search, BFS. Dynamic programming, a method to solve complex problems by breaking them down into simpler subproblems. This technique is often used in optimization problems. Greedy algorithms. Algorithms that make locally optimal choices at each step to find a global optimum are often used in tasks like scheduling and resource allocation. Divide and conquer, a technique that divides a problem into smaller subproblems, solves each one independently, and combines their results. Quicksort and merge sort are classic examples. Importance of data structures and algorithms. So, why are data structures and algorithms important? When studying computer science, we all think that the data structures and algorithms class is difficult to understand, boring, and especially easy to fail if we are unlucky enough to meet a professor who does not explain the lesson thoroughly. However, to become a good programmer, understanding the theories and how to use each data structure and algorithm in each different situation is a must. It not only helps us increase our logical thinking when coding, but it also helps us have a solid programming foundation to solve complex problems. Another factor that makes data structures and algorithms important is that many big tech companies like Amazon, Meta, Microsoft, Apple, Netflix, or Google require candidates to have a solid grasp of theory, as well as be able to solve problems using data structures and algorithms in the coding interview round if they want to join the company as a software engineer. In the description below, AlgoSync offers a variety of resources to help viewers learn and practice data structures and algorithms. You can explore these to find the best tools for your learning journey. If you like this video, please like and share this video or comment below to support AlgoSync. You can join the group's Discord in the description part to connect with people who are passionate about programming. Thank you for watching the video.